I'm happy to have with me here on stage, right next to me, Björn Rösner. He is Business Development Manager of Wurth SA, and Klaus Ullrich, opposite of me, Head of Sales Electrolysis of Sunfire GmbH. Mr. Rösner, Wurth is headquartered in Luxembourg. That's because I have to say Wurth, not Wurth. Wurth. It's
correct.
Lutzelburgisch, I think it's the word. Okay.
Right.
And you're the worldwide leading provider for equipment and plants for the metal industry. Tell us a little bit about your company.
For sure. I'm happy to see so many people on a Thursday afternoon here. And we are an international engineering company. As you said, with the headquarters in Luxembourg. We have a long history. Next year we celebrate 150 years of company history, and we are a leading player in the design and supply of complete blast furnace and coke oven plants, which is the primary stage of integrated steelmaking. We have more than 1,500 employees worldwide. We are a global player, and we are part of the SMS group, who is the leading player in the world of metals.
You only build these plants. You're not producing steel.
We are not operator.
Okay.
No.
You're not operator.
We are
you're just
plant building engineering company.
All right. Okay. To understand that correctly, Mr. Ullrich, the Sunfire is developer and manufacturer of high-efficient electrolyzers and also of fuel cells.
You're absolutely correct. Good afternoon, ladies and gentlemen. Yeah, the question is, what is Sunfire doing? And we are a startup, contrary to a large company. We're acting globally, yes. And we are the technology leader on high-temperature electrolysis. Majority of people probably know about PEM or alkaline, but you should and need to be aware there are additional technologies around. And us specifically is the highest efficiency technology. This is where its application in industrial segments like the steel industry we're going to talk. And certainly Sunfire exists for a few years as a startup since 2010. Is about 100+ people now and doing, as Ullrich perfectly stated, fuel cells and electrolysis. And to be remembering, this is the same stack. So we have one unique stack capable of doing many things.
You said there's another technology apart from PEM technology, but most people know. Your technology is called solid oxide electrolyzers, correct?
Yeah. There are PEM or alkaline, which are basically low temperature electrolysis, and they be taking water. But in industrial environments, where you often see steam being available in excess than needed, there is a good reason for taking the steam directly into this technology. And as such, we're hitting efficiencies which others cannot meet. So we're hitting 80+% from the intake of the electricity in AC, important to remember, to the hydrogen produced in the lower heating value. This is unmatched from any contenders. And the number, if you want to remember, that we have at least 30% less electricity need for the same volume of hydrogen to be produced.
Much more efficient indeed, and solid oxide technology is therefore very much suitable within industrial surroundings. Huh? Okay, yeah. Very good.
And since we're going to speak about steel in a moment specifically, certainly we have applications in chemical industry, in refineries. We just announced a contract with a utility company who is looking into fluctuating resources from the renewable energy. So there are all good reasons to take hydrogen as the next energy vector in various segments.
Mr. Rösner, and in January this year, Wurth decided to become lead investor in a startup like Sunfire. Why did you do that?
Yes, because we are active in the traditional iron and steel making, and we have already developed a lot of short-term and mid-term solutions to help our customers to reduce CO2 emissions. The steel industry is a huge CO2 emittent, so 6 to 7% of worldwide CO2 emissions come from the iron and steel making. And from this amount, approximately 85% belong to the primary stage of steel making, where Wurth is active and building plants. And we want to help our customers who are facing the problems to reduce the CO2 emissions on this way, and also want now actively go ahead with long-term solutions where we can substitute the carbon with hydrogen to reduce the iron ore.
It's quite interesting because most people think about energy transition. They think about electricity should be renewable. They think about the heating. Our houses should be warmer. They think about mobility maybe, but few people think about industry. And to be honest, steel industry, for instance, they producing tons of CO2 each year, don't they?
Yes, that's correct, and that's why it's significant that also in the steel industry there will be a transformation to carbon reduction, and I would call it defossilization. A lot of people call it decarburization, but we need carbon, and we also need carbon in the steel, because only then it's steel and not iron. But we need it in the process, and we don't need it in the air. And we want to try to substitute the carbon as a reducing agent with hydrogen. And yeah, that's why we decided to partner up with Sunfire.
So you need carbon for the reducing process together with hydrogen. And usually if you need hydrogen, you get it by reformers, probably. Natural gas with reformers, is that right?
Correct, yes.
You might see the slide now. Yes. Oh, there it is already. Thank you.
Yeah, on the slide, as you can see, we have shown the conventional steelmaking process, and right next to it on the right side, a proposed process, or this will be the long-term goal for the steel industry. Yeah? To be able, with renewable energy, to produce green hydrogen, and then use this in the steelmaking process. Already today we have direct reduction plants next to blast furnace plants, and they produce reduced iron with the help of natural gas. This already saves a lot of CO2 emissions, but even the natural gas is possible to substitute with hydrogen. And then you have very, very less CO2 emissions, and the technology is already available today. And yeah.
Maybe, Mr. Rösner, I didn't get that really. So you have to explain that, because I'm not from the steelmaking industry at all. So there are two ways to make steel. The one way is with coke, and the other way is with direct hydrogen. Is that right?
So maybe we sort it up a little bit more. There are two ways. There's a primary route and the secondary route. Primary is from iron ore, secondary from scrap, steel scrap, so recycling. Recycling. And in the primary route, there is normally the blast furnace route, which is dominant in the worldwide steelmaking process.
How many percent around? More or less?
It's 70% blast furnace route and 30% recycling. Yeah. And then the dominant route is the blast furnace route from iron ore. But we can also use the direct reduction. Yeah. And this is a reduction furnace using natural gas.
And direct reduction is already much better than the conventional way, yes. Even if you use natural gas.
And that's also the way many steel companies are going. They have they have feasibility studies, concept studies. They have done everything. They have a roadmap, a clear roadmap, how they want to go ahead. And they will start probably because the hydrogen is not available in these huge amounts and in this economical conditions. We need it. They will start with natural gas, which saves already a lot of carbon dioxide emissions, and then stepwise go increase the hydrogen content in this process until they reach 100% hydrogen and a very natural, environmental friendly process.
And this hydrogen, Mr. Ullrich, can be completely green if it comes from renewable energies, correct?
You're absolutely making the point. I think what we all have to remember ourselves is this happened for the reason of climate change, which we discussing and talking on other many forums. But not doing anything and stay where we are is not the option. So what we're looking into having everything electrified, what could be directly electrified from renewable, but you're correct, there are limits on electrification. And if you're looking to the broader industry segments, there is a lot of CO2 emitted. Sometimes you can avoid it, sometimes you can't, like in the mentioned industries. or in the cement industry. So what you need to do is looking for all alternatives you can make. And one of them certainly is reducing already the hydrogen which is produced based on fossil gas, like on a steam methane reformer. And the magic number is that for each kilogram of hydrogen, a steam reformer would be producing about 10 kilogram of CO2. So you see already the link that hydrogen substituting other hydrogen means makes a lot of sense. And that's the new energy vector of green hydrogen, making sense in steel industry, transportation, and we have a lot of other applications here already.
But how can you make sure that the hydrogen that you're producing in a steel factory will be green? How can you ensure that? You need a wind power plant right next to it.
That is the trick question of the day. Well, there is a lot of effort in the German legislation in Brussels and so on to put routes and clarifications in place to assure that. On the electricity, basically, even if you have a supplier of electricity to your house, to your factory, you'll be able to buy a certificate because somewhere else it's been produced. And this is kind of transferred into now the green hydrogen molecule strategy. So there are projects across Europe who are exactly looking into what is the future, let me say, act on defining this molecule is considered green when produced on electricity. Well, the most easy for sure is to have a direct connection of renewable energy provision like water for like solar or else. But
it's not always possible.
Reality is always more complex.
Yeah, okay, of course. But this is the goal, to have green hydrogen implemented in the steelmaking process. And Mr. Rösner, this is not rocket science. It already exists. It is applicable. So why does not everybody do it?
Yes, so it's already available process technology. The direct reduction we just talked about is possible to do with 100% hydrogen. Today it is done with natural gas with the reformer, and then also hydrogen enters the process. And not everybody is doing it, and also nobody will do it. It will not become a reality when we don't have a change in the political framework, in economical conditions. We need a level playing field for all the steel making plants because steel is a global market, and then it's not helping our industry in Europe, in Germany, when we decide we want to do it with hydrogen, which is at the moment expensive. There also need to be huge investments done in the technology to build it. And yeah, we need instruments, funding tools, that this is possible. Yeah?
It has to be competitive on the world market. Otherwise, we can't have the situation that we import steel from China with a very bad carbon footprint.
Correct. It's called carbon leakage.
That's a carbon leakage then, yeah.
Somewhere else are less strict requirements or policy frameworks. The steel industry might have the problem to move away, to be produced elsewhere and not as clean as they are doing it today.
Mr. Rösner, so what would you propose then? We have the emission trading system, which not really works. We have to build it up once again, or what would you say? What do we need?
Yeah, the emission trading system, ETS, in the EU is not really working. The steel industry is, I would call it, paralyzed at the moment because the prices are too less to really push investments, but they are too high to be competitive in a worldwide market. Yeah, we could think of the policy has to make the right framework. I don't have the right vision at the moment.
Mr. Ullrich, maybe only a clear political roadmap would help how to get to carbon-free or carbon-reduced steelmaking. That would help, huh?
Yeah, definitely. But as Björn mentioned, this is not on a European level to be discussed because we are running our companies out of competition in this moment. And the CO2 molecule is probably taking less than 24 hours to come back to Germany. So it matters globally. This is the important message. And from the aspect of the steelmaking, One of our existing customers, while we are pleased Paul Wurth joins us as a manufacturing intelligence globally acting, we had already steel manufacturing customers in Germany, and they had put, please come D46 later and we can discuss more detail. They have put a one-pager announcement in German newspapers this week on Monday, like in Handelsblatt, basically with the clear message, we are ready to do. They have already experienced replacing means of producing the steel into renewables. Basically, the message is we can go on 95% CO2 reduction for the same quality of steel. But it's a question to the politicians. You need to make it happen by guiding us to not run ourselves out of business. And from that specific customer, back to the efficiency, the CEO and the chief executive of the board confirmed in the past already in public that this technology we have, like the high temperature, is the most efficient in application wherever steam is available, which is available in the steel manufacturing.
Mr. Rösner.
Yeah, I would maybe add one example. You asked me about what would be a way. For example, it could be a way if the steel, which is used in a car, we just say we need to use green steel. Huh? And then a mid-sized car will not cost 50,000 euro, it will cost 50,200 euro. Yeah? And
it's not that much, is
no,
it? Yeah, yeah.
And then we're done. Huh? And we have green steel production. We can leave the steel production in Europe, in Germany, and it just need to take some decisions from the politics.
And it has to get into the public awareness as well that steel is not just steel and it exists and it grows on plants, but it is produced by producing a lot of carbon, of course. I would like to open the stage for your questions. If you have any questions, just raise your hand. I'll be with the microphone right with you. That's not the case at the moment. Mr. Rösner, I'm a little bit curious. You don't have to tell me names, but you just offer it to your customers, of course, this new technology. And are they really interested, or say, well, no, we are an international competition. No way that we implement such a thing like electrolyzer from sunfire?
Yes, they are very interested, and it's not new technology. So from the steelmaking process side, it's not new technology. Electrolysis is also not new technology, but it's becoming more available at scale. Yeah? So megawatt plants are coming, and they become bigger, and also the hydrogen will become more economical. But from steel-making industry perspective, the process are known, they are available, they are producing millions of tons of steel worldwide, and the customers have already done all these concept studies, feasibility studies, they have pilot plans already running, and the roadmap is clear. But as I said before, right now it's unfortunately not economical.
Okay. But Mr. Ullrich, in the long run, you have another idea, another arrow to throw. That is, you can, with your solid oxide electrolyzers, can do power-to-X direct production of liquid fuels. So the big discussion about e-fuels is also possible, also in an industry surrounding.
Yeah, this is one of the uniquenesses of this technology, which others cannot. We spoke about the efficiency, which is one chart to remember. If you want to take a message away. And we're taking now into liquids or other means of, and it's called power to X. Power to X can mean anything, but the end product can be defossilized in the terms of substitute of crude oil. We call it a blue crude or an e-crude. So there's a lot of things possible, but what you mentioned is a direct injection of the CO2, which is already enough and more than we need in the air, or from subcontracting or contracting out of waste streams of industrial waste. And this can be going directly together with the electricity into the same process stack. And then we have a syngas, which is sub-processed further into basically liquid fuels. And we have pre-qualified from Audi that the synthetic fuel we have is prime quality. We have certified kerosene that is being drop-in quality already. So again, technology-wise, the stuff is ready. Commercial, well, we need to scale. The scale, well, it needs to be guided by legislation. And we're back to the same question.
So a lot of opportunities. It's possible to make our industry green. There is technology there. There are big manufacturers of steelmaking industry who are ready to do so. So that's just hit the road. Gentlemen, good luck for that. Thank you very much for your attention. And thank you for this interview here on stage. Thank you.
Thank you very much.
Thank you, Ulrich.